So, today what we will do is learn how to graph a quadratic function. This is the function we will be graphing today. This is just an example. Before we start graphing, we need to convert this function here in standard form into a factored form equation. This one is not this one. Just putting it out there. Okay, the first thing we do is we have to graph the function by finding the x-intercepts, the y-intercept, and the vertex. The easiest thing we can do when the function is written in standard form is the y-intercept. Why? Because the constant is the y-intercept. What is the y-intercept is when the x equals 0 and then there's a y value next to it. And this is the y value. So it would be 0, negative 24. This is the y-intercept. Now, what we have to do is, like I said before, turn this function in standard form into factored form. What we have to do is using the square technique. This is just to help you how to turn it into factored form just a bit easier than just doing it off the top of your head. And we put this little square, and in this square it is divided into 4 sections, and in each section we put a number and or a variable. We have to put this thing into this square. So the things we know right now is the y-intercept and the x value part. So we put the y-intercept, the constant, in this bottom right corner here, and the x squared part into the top left corner here, 2x squared. Now, what we know on how to get to 2x squared. We know that getting to x squared is basically just x times x. And to 2x, there's only one other way to do it, is 2x times x. So that's what we will put here. 2x times x. One quick thing to note about the square is that this value times this value is what equals to this square. This one times this one is what in this square. This value times this value in this square, and this value here from this value will multiply together to give you this square. So now, this times that, there are 6 different ways that we can get 2 different numbers multiplied together to equal negative 24. And these are the following. Negative 6 times 4. 6 times negative 4. Negative 12 times 2. 12 times negative 2. Negative 3 times 8, and 3 times negative 8. There are 2 possible ways we can use this to find them. So, for example, we'll be using 2 of these to write 2 different factored form functions that work and are converted from this one. So, let's try, for example, using 12 and negative 2. Well, let's put 12 up here, and negative 2 down here. What do we multiply to? We multiply negative 2 times 2x is negative 4x, and 12 times x is just 12x. If we add these 2 together, it won't give us negative 2. By the way, adding these 2 will give us the bx value here on the standard form equation, and it doesn't. 12x minus 4x give us 8x, not negative 2x. So it is not 12 and negative 2. What other value could we use? Well, let's try negative 6 and 4. How about that? We put let's put negative 6 up here and 4 down here. what is 2x times 4? It is 8x, and negative 6x times x, negative 6 times x is, well, negative 6x. And by adding these two together, it will not give us negative 2, but it will give us 2x, positive 2x, which is not what we're looking for. So negative 6x and 4x is not the answer. But what if instead of negative 6x, we just put the negative in front of the 4? Now yes, now this will work, because now the 8x is from positive 8 to negative 8. And negative 8x plus 6x will give us negative 2. Give us this value. And yes, now these two multiplied together will give us the factored form version of the standard form equation. Let's write it out. So, this value here in parentheses times this value here in parentheses will give us the factored form. Let's write it out. 2x plus 6 times x minus 4. This function right here is the same function. If you were to graph these two functions, you will see that they are the same. If you will put them in a table and plot every x point, every x and y point, they will all be the same. But we can use another one of these combinations to find this exact same function. And what will they be? Well, but we haven't tried 3 and 8 so far, so let's do it. What if we put an 8 over here and a 3 here? Well, should we put the negative? Let's put the negative down here. Now, 2x times negative 3 is negative 6x, and 8 times x is 8x. Add these two together, it will give us positive 2, not negative 2. That's not what we're looking for. So, we put the negative on the 8 instead of the 6. Now negative 8 times x is negative 8, and 3 times negative 2x is 6. Now, we add these two together, it will give us negative 2, which is what we are looking for. So, we just found two ways that we write this one in factored form. And this is negative 2x minus 8 times x plus 3. Now these are our two functions converted from standard form to factored form. Okay, so now what we have to do is find the x-intercepts using the factored form equations. For the sake of simplicity, we're just going to use this one right here, 2x plus 6 times x minus 4. Just going to use this one. And to find the x-intercepts, we have to look at two rules. The zero product property, which is when any number multiplied by 0 will always equal 0. There are no exceptions to this. And the x-intercept, the y value of the x-intercept is always going to be 0. Here's an example. 3, 0 and 4, 0. 3 and 4 are both x values, and y value here is 0. You see, is always 0. So what we're going to do here is, for example, let's take g of x. Let's say, using factored form, that the first value is 0 and then multiplied by 4 will always equal 0 no matter what. What if it's the other way around? G of x equals 6 now times 0. It will always equal 0. Okay, so what I just wrote down here, let's apply it to this, for example. We have to find a value, an x value, that will make one of these equal 0. Why? Because we want to find the x-intercept. And an x-intercept is when we take an x value, let's say, for example, positive 4 is an x value that is the x-intercept, 4, 0. One of these will equal 0 and the other one will equal another number. For example, let's take f of 4. We're not using this example, it's just another example. Let's say this will equal 7, for example, I don't know. And this one equals 0. These two multiplied together equal 0. So, f of 4 equals 0, meaning that the point 4, 0 is an x-intercept. So, now let's actually try to solve for the x-intercepts of this equation. Let's take this, for example. We're trying to make this equal 0, because no matter what number we get here, we'll multiply together to equal 0, therefore meaning that it is an x-intercept. So let's take 2x plus 6, and we equal it to 0. We're trying to solve for x now to see what value will give us x, 0. So we just solve for x normally. Negative 6 equals 2x divided by 2 here, divided by 2 here. X would equal negative 3. This negative 3, x equals negative 3, is one of the first x-intercepts we found already. Why? I'll show you in a bit. Here we have the first one, negative 3, 0. We're missing another one. Let me explain. Now we're just trying to make this equal 0 and this, whatever number we get, because they're multiplied together will equal 0 anyways, therefore giving us an x-intercept. So this one is way simpler to solve, just x minus 4 equals 0, plus 4, plus 4, plus 4, x equals 4. 4 is the other x-intercept we found so far. So now we have both x-intercepts in this function, 4, 0, and negative 3, 0. Okay, so now we will have to find the vertex. It's one of the last points, it's the last point we have to find in order to properly graph this function. To find the vertex, we first have to find the line of symmetry. The line of symmetry is the exact middle where the vertex is, and it is the exact middle between the x-intercepts or any other point that has the same y value. So the x-intercepts, for example, they will have the same the y value, 0 and 0. If we take another point, I don't know what this point would be, but it would be another point x, negative 24. We could also find it using that, but it's easier to find using the x-intercepts. Here, let me show you. So how do we find the line of symmetry? We take both points. We have the x values of the x-intercepts. We have negative 3 and 4. To find the x value of the vertex, we have to add these two, negative 3 plus 4, and then divide them. So this will give us 1 over 2. Now, we have found the x value of the vertex, which is 1 over 2. So what do we do now? We have the x value. If we have an x value of a function, we can plug it into the function, and then we get the y value, which is the y value of the vertex. We have the first point here, half, comma, and then we still have to find, which we'll do now, right now. Let's put it into the function. F of half is equal to 2 half squared minus 2 half minus 24. I would just solve. What is half squared? So half squared is a quarter, 0.25, or 1 over 4. and we just multiply times 2, and then minus 2 times 0.25 minus 24, and this will give us 0.25 times 2, which is half, 0.5 minus negative 2 times 0.25. Wow, negative 2 times 0.25, negative half, minus 24. And all of this added together will give us 0.5 minus 0.5 minus 24 will give us negative 24. Okay, there was a slight miscalculation. Sorry about that. But half squared is 0.25 times 2. And negative 2 times half is just negative 1. There was the slight miscalculation. I thought this was squared. I'm sorry about that. Minus 24. Now, we do this, which would equal 2 times half is 0.5 minus 1 minus 24 will equal 2. Here, let me do the calculation. 0.5 times 0.5 minus 1 minus 24 is negative 24.5. Negative 24.5. And this is our y value for the vertex. Negative 24.5. And we found our 4 points necessary to graph the function. Okay, so now we have our graph here, and all we have to do is just plot the points we found. So, the x-intercepts first. Negative 3, 0. Here we have negative 3 on the 0. Put a 1 point there. And 4, 0. We have 4 here. Put a point here. Now the y-intercept. Here we have the x equals 0 and negative 24, which is all the way down here. We plot a point here. Now, the vertex, which is on half, these lines all count as a half, so half, 1, 1.5, 2, etc. So, half, it's on here, and negative 24.5, which is right around here. All we have to do now is just make the parabola. And here we have our graph. Not the best looking, but it does the job, and we have all points plotted here. Make sure to always put the points in parentheses to make sure you are correct. And there you have it. This is how we graph the function from standard form, change it into factored, found the x-intercepts, the y-intercept, and the vertex. Thank you.